Good day, students. In this clip, we're going to be going over some problems reviewing the whole process of derivatives. So let's go ahead and take a look at question number one. So for problem one, we are to find f prime of x if f of x is equal to 2x squared, 2x squared plus 3x. We're to do this using the definition the limit definition of derivatives using the um, limit definition of derivatives, okay? All right, so if we wanted to use the formulas, it would be easy for us to compute what this derivative is. So let's do that on the side. So f prime of x using the power rule is going to be 4x plus 3. Okay, so when we use the limit definition of derivatives to find the derivative of this function, we should expect to get 4x plus 3 as our final answer. All right, so let's write down what the limit definition of derivatives is first, and then we'll go ahead and start looking for the derivative using the formula. Okay, so the formula, f prime of x, there are two of them, but this is one that I'd like you to use. Limit as h approaches 0 of f of x plus h minus f of x, and this divided by h. Okay? All right, so let's go ahead and apply that to this problem. So f prime of x is going to be the limit as h approaches 0. Now, f of x plus h is what you get when you replace the x's in f of x with x plus h. So we're going to have 2 times x plus h quantity square plus 3 times x plus h. This is f of x plus h minus f of x is going to be parenthesis 2x squared plus 3x. Okay, do not forget the parentheses when you have the minus here. That's a common mistake most uh, students make, so keep that in mind. And that over h. We can clearly see that plugging in, directly substituting h into this equation will be problematic because we'll be dividing with a zero value which is undefined. So what we have to do is simplify this equation, this expression completely, and then we can plug in 0 for h. Okay, so let's go ahead and expand this term, x plus h squared. If you expand it, you're going to have 2 times x squared plus 2xh plus h squared. And then distribute 3 to this, you're going to have plus 3x plus 3h. And then here, just distribute the negative, you have minus 2x squared minus 3x. The entire numerator divided by h. Okay, we're still taking the limit. Okay, so let's see what we can do here. We can distribute this 2 to all these terms here. So when we, and also if you note the 3x and the 3x, this one's cancel out right there. And then let's go ahead and distribute the 2 to everything. So we're going to have the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared plus 3h minus 2x squared. That entire numerator divided by h. Okay, now let's see what happens in the numerator. You notice that let's see, 2x squared minus 2x squared cancel out. So anytime you do this correctly, the terms you're left with after simplifying the numerator completely must have h as a common factor. Okay, if you can't factor out h from what you have left after simplifying the numerator completely, then you made a mistake somewhere. Okay, so you can clearly see that h is common in these 3 terms. So what we're going to do, that's going to enable us to factor out the h and cancel it with the denominator, all right? And then we can plug in 0 for h without any complications. So let's go ahead and factor out the h. Factor out the h, we'll have h factored out, 4x plus 2h plus 3. That divided by h. Okay, and then you have some cancellation action happening here. You can divide the top and the denominator by h, and then you have the limit as h approaches 0 of 4x plus 2h plus 3. Now we can just plug in 0 for h, and that's going to leave us with 4x plus 3. All right, because this term attains a value of 0. And there goes your derivative, and we can see that it checks out with what we expected for f prime. Okay, so that's what f prime of x is, 4x plus 3. All right, let's move on to the next question. All right, so for problem 2, we are to find f prime of x if f of x is equal to the inverse sine of log base 3 of x to the third plus 2, that entire expression divided by cosecant of 4 raised to the x to the third power. All right, so we can see here that we're going to have to use the quotient rule. All right, so the numerator is u, and then the denominator is v. Okay, let's review the quotient rule real quick. U over v prime is equal to vu prime minus uv prime over v squared. Okay, so that's the first formula we're going to use. Then when we're looking for u prime and v prime, we're going to talk about other formulas. Okay, so what we're going to do is, since u and v are very complicated, we can differentiate them individually, and then we're going to just plug the respective values into this derivative function right here. All right. Okay, so let's go ahead and list them. So let's start with u. Extracting the numerator u. U is the inverse sine of log base 3 of x to the third plus 2. All right, we're going to be using the inverse trig function for sine, the derivative of that, then the derivative of logarithm base b, and then the power rule to differentiate this polynomial function in here. Okay, all right, so let's review the formulas that we're going to be using here. So the inverse sine of x prime is going to be is 1 over the square root of 1 minus x squared. Okay, and then the derivative of log base b of a, if you differentiate log base b of a, that's going to be 1 over a times the natural logarithm of b. All right. All right, so let me change the variable for this one here so you don't get confused as viewed as a constant. So let's say we're doing log base b of x. So it's going to be 1 over x times the natural logarithm of the base. Okay? And then we know what the power rule is. All right, so we're going to use these two formulas to find the derivative of this function. We're going to be using the chain rule here. Okay? So let's go ahead and take a look at, we're going to start u prime. We're going to start with inverse sine. So when we're doing inverse sine, log base 3 of x to the third plus 2 is going to be our u. Okay, so we're going to leave that fixed and then just differentiate the outside. So let's use this formula right here. We're going to have for u prime 1 divided by the square root of 1 minus u in this case is going to be that. So the square root square root of 1 minus this entire argument prime square, so 1 minus log base 3 of x to the third plus 2 square. Okay, so that's the derivative of the outer function. Now, using the chain rule, we're going to shift our attention to this log base 3 of this term right here. Okay, So using the chain rule, this will be our u. So if we take log base 3 of u, it's going to be 1 over whatever u is, which is x to the third plus 3. So x to the third plus 3, plus 2, multiplied by the natural logarithm of the base, which is 3. So ln 3. Okay? So that's the second function. Now we're going to go to the innermost function, which is x to the third plus 3. Using the power rule, that's simply going to be 3x squared. All right? So there goes u prime. So let's write it. Let's make it look pretty. So u prime is basically going to be 3x squared divided by, in the denominator we have ln 3 times x to the third plus 2 times the square root of 1 minus the log base 3 of x to the third plus 2 raised to the second power. All right, so that's u prime. All right, let's go ahead and look for v prime. So I'm going to split it down the center, see if I can fit it in here. So to look for v prime, we're going to have to first of all write down what v is. So let me move this to the right a little. All right, so let's write down what v is. V is the denominator, right? So v is equal to cosecant of 4 to the x to the third. All right, so there goes what v is. All right, so what's the derivative of, we're going to be using, to find v prime, we're going to be using the derivative of cosecant and also the derivative of a to the x formula. Okay, so let's list the formulas we're going to use here before we find the derivative of v prime. So we know that, let's write it here, cosecant x prime is equal to negative cosecant x cotangent x. Okay, and then a to the x, if you have a constant raised to a functional exponent, that's indicated by a to the x prime, is going to be a to the x times the natural logarithm of a, of the base. All right, so there goes the formula for exponential functions. Okay, so let's go ahead and apply it here. So we're going to be using the chain rule. V prime is going to be, let's start with the outermost function, cosecant. We're going to hold this fixed, unchanged. So the derivative of cosecant is negative cosecant u cotangent u. So if this is u, it's going to be negative cosecant 4x to the, 4 raised to the x to the third times cotangent 4 raised to the x to the third. Okay? Alright, so we're done with the outermost function. Now let's shift our attention to the inner function. To differentiate that, that's going to be a to the x ln x. Basically, whatever you were differentiating, a to the x, you rewrite that 4 to the x to the third times the natural logarithm of the base times ln 4. And then we're going to multiply it by the derivative of the innermost function, which is x to the third, and that is going to be 3x squared using the power rule. All right, so that's 3x squared. Let's write that down, times 3x squared. All right, so let's go over what we just did again. So we differentiated cosecant first to get cosecant and cotangent, holding the inner fixed for x to the third, for x to the x to the third, and then we differentiated for x to the x to the third using the power rule here, exponential rule. So we had a to the x ln a, so this is a to the x, the original problem, times the natural logarithm of the base, which is 4, and then using the power rule for x to the third, we have 3x squared. Okay, so if we write it nicely, this v prime is going to be negative natural logarithm of 4 times, we don't have to put times it. Natural logarithm of 4, parentheses, times 3x squared times 4 to the x to the third, cosecant 4x to the third, 4 to the x to the third, cotangent 4 x to the third. All right. Okay, so let's put everything together to get our final answer. So we're going to be using the quotient rule. All right, so let's rewrite it here. U over v prime is basically v u prime minus u v prime over v squared. Okay, so let's go ahead and do it. We're going to have the final answer, f prime of x. We don't have to simplify too much, just write it as it is. So v is cosecant 4 to the x to the third times u prime, which is 3x squared. So we can put, let's put 3x squared here. Doesn't really matter. 3x squared over this entire thing. So it's going to be over the natural logarithm of 3 times x to the third plus 2 times the square root of 1 minus log base 3 of x to the third plus 2 squared. Okay, so that's v u prime minus uv prime. So u is the inverse sign of log base 3 of x to the third plus 2. Okay, so that's v, and then, that's u, and then v prime is this entire expression right here. So since we have a minus, it's going to change this to a plus, and then we can just put this entire expression in there. So it's going to be the natural logarithm of 4, ln 4, times 3x to the second power, 4 to the x to the third, cosecant 4 to the x to the third, cotangent 4 to the x to the third. Okay? Alright, so this is vu prime minus uv prime, and then that entire expression will divide by v squared. Okay, divide this by v squared. So v squared is simply cosecant square of 4 to the x to the third. Okay, so that's it. You don't have to simplify it any further. It's just this is good enough. So, all right. So let's go ahead and consider the next question, problem number 3. All right. So for problem 3, let's use a new page. We have to find the derivative of f of x equals the square root of x to the third plus x divided by the inverse secant of x to the third. All right. So to make this easy to compute, we can rewrite this function as x to the third plus x over the inverse secant or the arcsecant of x to the third, all this raised to the raised to the 1/2 power. All right. So the new formula we're going to be using here that I haven't gone over the formula is the inverse secant formula. So the derivative of inverse secant or arcsecant of x is 1 over the absolute value of x times the square root of x squared minus 1. Okay, so that's the formula. We're going to be using the chain rule here, so we're going to be using u for x to the third, and then we'll differentiate x to the third afterwards. All right, so let's go ahead and find the derivative. We're going to be using the chain rule first so that we can differentiate this radical function. So f prime of x, focusing on the radical function, that's going to give us, I like to use this shortcut to save time. You have to recall that the derivative ddx of root x, I shouldn't have written it like this. ddx of root x is equal to 1 over 2 root x. Okay? So you can use this to save time. So I could use that here instead of using the power rule, which would take forever. But since we have a complicated problem, we can always use shortcuts. Okay, so let's use this formula. I hope you see how this works because x to the 1/2, if you use a power rule, you're going to have 1/2 x to the negative 1/2, which is 1/2, 1 over 2 root x. Okay? All right, so if I apply that there, here I'm going to have 1 over 2 root u. Okay, 2 root u, but u is this entire argument of the radical function, so 2 root x to the third plus x divided by the arcsecant of x to the third. Okay? All right, we're done with the outermost function. Now we're going to shift our attention to the inner function. So to do that, we're going to have to use the quotient rule. Okay? When I'm using the quotient rule, u is going to be x to the third plus x, and v is going to be the arcsecant of x to the third. Okay? So let's go ahead and do it. We're going to do vu prime first. We already know what the quotient rule is. So v is the arcsecant of x to the third. V and then u prime, just simplify the power rule here. You're going to have a 3x squared plus 1. 3x squared plus 1 minus, this is v u prime, and then minus u, which is x to the third plus x. That v prime is going to be, we're going to be using a chain rule here. So first of all, we have 1 over the absolute value of u, which is x to the third, okay, times the square root of x to the third squared is simply x to the sixth. Let's just combine steps to save time, minus 1. Okay, so that's the derivative of the outer function, looking for v prime. And then if we differentiate x to the third, that's simply going to be 3x squared, applying the power rule to x to the third. Okay, so this is vu prime minus uv prime. Don't forget the denominator, that this whole thing divided by v squared. All right, so that's going to be v is going to be the arcsecant of x to the third. That's v, right? So we're going to square that. Okay, so that's the derivative. Let's just put it together. You don't have to simplify too much, but let's just put it together into one nice little fraction. F prime of x is going to be 3x squared plus 1 times the arcsecant of x to the third minus, now the numerators, I can put all the numerators here together, 3x squared times x to the third plus x, that divided by the denominator, which is the absolute value of x to the third times the square root of x to the sixth minus 1, and then this whole thing divided by, since we're multiplying two fractions, 1 times that is just what you had before, and then these two terms in the bottom will be your denominator, so it's going to be times 2 times the square root of x to the third plus x over the arcsecant of x to the third times the arcsecant of x to the third raised to the second power. Okay, so if you gave me this answer, that's fine. This is just trying to put it together. You don't have to simplify that much for these problems. I just want to make sure that you know how to make use of the rules of differentiation. Okay, so this is going to be your final result for question number 3. All right, let's take a look at question number 4. So for problem 4, we have y equals log raised 2 of tan 2x raised to the cosine of 3x plus 1. Okay, Anyway, when you have a situation like this, a function raised to a functional exponent, you're going to have to use logarithmic differentiation, okay? So let's go ahead and use logarithmic differentiation to find y prime. So let's write on what the problem is completely. If y is equal to that, find y prime, okay? So that's a task. So first thing you're going to do, if you want to use logarithmic differentiation, is to take the natural logarithm of both sides of the equation, all right? So you take the natural logarithm of y equals the natural logarithm of log base 2 of tan 2x raised to the cosine 3x plus 1. All right, so using the properties of logarithm, we know that we can power down this exponent. Power it down. So we are going to have the natural logarithm of y equals cosine 3x plus 1 times the natural logarithm of log base 2 of tan 2x. Okay? Okay, now, as you can clearly see on the right side when we're differentiating, we have to use the product rule. Okay, and we know remember what the product rule is. UV prime is equal to VU prime plus UV prime. All right, so that's what we're going to be doing here. In this case, we can see what U is. U is cosine 3x plus 1, and V is the natural logarithm of log base 2 of tan 2x. Okay, so let's go ahead and differentiate both sides. On the left side, differentiating implicitly, derivative of ln x is 1 over y times y prime. Okay, because we're differentiating with respect to x and the variables don't match, so we have to add this y prime component. All right, so now we're going to use the product rule. Phi is the natural logarithm of log base 2 of tan 2x. So that's v, and then u prime is the derivative of cosine. The derivative of cosine is negative sine, right? So let's put the negative up front here. Negative sine 3x plus 1. So that's sine, we're differentiating cosine u. Now if we differentiate the innermost function, this linear function will be times 3. All right, so this is vu prime plus u, which is cosine 3x plus 1. Now if we differentiate this, the natural logarithm of that is going to be 1 over, if you're looking for v prime, the derivative of v, of v is going to be 1 over u, okay, times the derivative of that. So it's going to be 1 over u, so I can just put, since it's 1 over u, let's put it right here, times 1 over, the denominator is going to be log base 2 of tan 2x. All right? Because we know that the derivative of ln x is 1 over x. Okay? So now let's differentiate. We're done with the ln. Now let's shift our attention to log base 2. Remember what the derivative of let's write it down so we don't forget. So you have log, so it's a weird one to remember. Log base b of x prime is 1 over 1 over x 1 over x times the natural logarithm of b. All right, so that's what we're going to have here. So it's going to be 1 over x is tan 2x. Okay, so it's going to be 1 over tan 2x times the natural logarithm of the base. What is the base? 2. Okay, 1 over x is 1 over tan 2x times the natural logarithm of the base. All right, and then lastly, we're going to look for the derivative of tan 2x. Okay, so what's the derivative of tan? Remember what the derivative of tan is. Let's recall. Tan x prime is secant square x. Okay, that's the derivative of tan. So if we differentiate tan 2x, we're going to have to use the chain rule again. Let me shift it to the left a little bit. So u is 2x here, so derivative of tan u is going to be secant square u. So we're going to have secant square 2x. Now to differentiate 2x is going to be just 2. Okay, so there you have it. Now what we're going to do is we have to multiply both sides by y, right? So we'll multiply both sides by y. We're going to replace y with its value, which is this logarithmic value right here. Okay, so we're going to replace that and then times this entire expression. That will be what our final result will be. So if I multiply both sides by y and substitute the actual value of y, so what I'm doing now is I'm multiplying this side by y, multiply this side by y, and multiply this entire equation by y. Okay, so multiplying and replacing with the original value. The original value of y is log base 2 of tan 2x. That entire thing raised to the cosine 3x plus 1. Okay, that was what y was originally. Okay, right here. And then that times this entire expression right here. Okay, so times, let's see how we can make this look better. We can just bring the 3 to the front. So it's going to be minus 3 times the natural logarithm of log base 2 of tan 2x. Log base 2 of tan 2x multiplied by sine 3x plus 1. And then we can compress this easily. Compress and make it look a little bit nicer. So if I compress the numerator, just multiply the numerators across. I'm going to have 2 cosine 3x plus 1 secant square 2x. And then that divided by the denominator, which is log base 2 of tan 2x times tan 2x multiplied by the natural logarithm of 2. Alright, so there goes your final answer for question number 4. Okay, so there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel so you can get future updates. There are going to be more parts to this review series, probably 2 more parts. Please post a comment to let me know what you think and click like if you liked it. Thanks again for watching. Have a wonderful day.